This is chapter 3. Chapter 3, hematopoiesis is where we're at. Okay? So, talk a little bit more about a bone marrow. What a bone marrow does. We're talking about bone marrow is the production, the main production of. You okay?
Yeah, she's like.
Oh. Just make sure you wasn't falling down.
She gets up, but she's gonna fall over.
I know that you get up, I start worrying.
It's like all eyes on the girl.
Everybody look at Eve.
She's so bright and shiny.
She comes in last. We get to look at you when you get back. Fifth. Everybody agreed on the fifth for the final exam. Okay? Alright, so your bone marrow is basically where all hematopoiesis occurs in adults. There are other sites, but it is the big site where it occurs. Okay, we do have a little bit in the liver, a little bit in the spleen, but not enough to compensate for the bone marrow. The bone marrow does play the major role. Okay. The endosteal compartment. This is basically the bone part. This is where bone remodeling occurs, and it also contains your HSCs, okay, which are your hematopoietic stem cells. Okay, so in your book it abbreviates it HSCs all the time. So, but it stands for hematopoietic, okay, stem cells. So these are the cells that are going to basically form your white cells, red cells, and your platelets, okay, the macrophages in general, all right? Okay. This is your endosteum, is this little area right here. Of course, your bone, your blood vessels and different things will also go through the endosteum. Remember yesterday or Monday we talked a little bit about how that sometimes you have little niches where the cells are being formed. Remember I talked about we have what's called an erythroblastic island. I talked about it has a big macrophage in the middle and then cells surrounding it. Okay, that's kind of what this is referring to. Okay, so you got your erythroblastic island, then you have your granulocytic nest. So this is going to be like segs and eos and basos. They're going to kind of be hanging out in the area. All right, and then you have actually a little bit of lymphoid aggregates too. But they're not going to hang out long, all right? And then, of course, you have your megakaryocytes, which are the ones that make your platelet. Adipocytes, or adipocytes, which are basically just cells that have fat in them, is what they are. And then, of course, you do have blood vessels coming in and out, okay? Your lymphoid aggregates are usually going to be close to a blood vessel somewhere because they need to get into the bloodstream so they can get to the lymphatic system. All right, very easily. Notice your white cells are also there, okay, close to blood vessels. And then your erythroblastic islands, they're kind of just interspersed all through, okay? Now, the white cell aggregates are not going to be as easily identifiable on a slide, on like a microscope slide like the erythroblastic islands will be, okay? We're going to start looking at some bone marrow slides probably next week. Next Tuesday in lab, I'll pull out some bone marrow slides and let you just kind of look at them, all right? Don't expect you to count them because there's going to be a bunch of immature cells, but just let you look at them. And you can kind of scan over them. You can see like the clusters that we're talking about, okay? All right, so you have to have vessels, right? We have to have vessels go into it. So everything that is living in our body has to have two types of vessels. What are they? Have to have arteries and they have to have veins. That's right. So a lot of times we actually have two arteries that go to our bones. Every one of our bones, especially where to the ends where the red marrow is located. We have a nutrient artery, and then we have what's called the peristeal artery. The peristeal basically is just two arteries. And you ever seen the word foramens? Yep. Okay, those are little holes that are in your bone. You guys ever look at bones? Yeah, y'all take an anatomy. So foramens are holes in the bones. They can either be where nerves go in or they're where vessels go in most of the time, okay, and supply different things. And then it all drains out through what we call a central vein that comes out through the bone marrow. Okay. The nutrient artery braces into several sinuses. What's a sinus? It's a cavity. It's an opening. It's a big opening inside your head. But here we have them inside the bones. Remember those the trebulae that I showed you a picture of that have those big mesh looking. Those openings are considered sinuses. All right, and that's where most of this stuff's going to be taking place, in the sinuses of the bone marrow. Okay, as we go through. All right, and then just remember, arterioles, of course, are small arteries. Remember from phlebotomy, I taught you guys that it's arteries, arterioles, capillaries, venules, and then veins. Okay, and so arterioles meet capillaries, and then venules, capillaries meet venules. Okay, as we go through. All right, those are the sinuses, usually lined by a single layer of endothelial cells. All right, they have a unique cell called a reticular cell. Okay, and this reticular cell plays several roles. One of the roles it plays is it produces cytokines, okay, which are basically chemicals that kind of control how the stem cells react, okay, to different things. All right, and then we have what's called the central longitudinal vein. Of course, if it's a vein, it's carried the oxygenated blood away. And then we have nerve fibers that are going to come in. So if we have nerve fibers, can we feel our bone marrow? I mean, can we get pain in our bone marrow? Sure, you can. You can get pain. Multiple myeloma is a leukemia. It's a type of leukemia. It's a plasma cell leukemia. But that's usually one of the characteristics of it, and one of the first things that sends the patients to the doctor is their bones start hurting. And what it is, their bones are actually being deteriorated. And so a lot of times they would call it bone cancer, but it's really multiple myeloma is what usually the diagnosis is. Okay? All right? So you got three, these are the parts of the bone. If you were looking down into the bone like a cross section of bone. So you got the peristeum. You know what the peristeum is? How many of you like ribs? I like ribs. Do you know the bone?
Yep. Well, not
You don't know the bone? You don't know the bone?
I know.
So like you eat all the meat off of it, and then you get down, you get that little thin membrane that comes off, and then you got dry bone. That's the peristeum.
It's the thin layer.
That thin layer that surrounds it. When you can gnaw that down and get it down and pull it off, and you get that dry bone. That's the peristeum that you just ate of that particular animal. Okay. All right. So the peristeum. Then you have osseous bone, which of course is the dry bone, and then you have the endosteum. And this endosteum is a little layer too, and it's usually just endothelial cells that are there. Okay? And then of course you got your bone marrow inside here, and then this is basically your vascular system of this. Okay? Alright, the stroma. The stroma is basically your supporting scaffolding of your bone marrow tissue. Okay? Plays a role in support, but it also plays a role or an area for adhesion of these cells. Okay, so basically, like those reticular cells that we talked about, macrophages, those erythroblastic islands, whatever, they can't just kind of hang out suspended. So what they do is a lot of times they are attached to the stroma of the bone marrow. Okay, so it's kind of like a matrix. The stroma is a matrix. In other words, it's like a filler of the inside of the bone marrow. Okay? All right. Stromal cells produce cytokines that regulate hematopoiesis. Remember, cytokines are just chemicals that signal things, okay, in general. And in this case, it may be differentiation, it may be apoptosis, whatever, okay? But they're going to play a role in letting cells know what to do, okay? Stroma is composed of three major cell types that we have. Macrophages, all right? What are macrophages? Let's get that out of the way, all right? You guys have probably heard macrophages your whole life, but don't know what they are.
Macro would be big.
All right? So macro are large, okay? What's a phage? Or what's phage when we talk about that? It engulfs it. What are we referring to? What's the biological term that we're referring to? Phagocytosis. Very good. So macrophages or macrophages are basically large cells that phagocytize things, okay? Not only like bacteria and these kind of things, but they will actually phagocytize cell parts, okay? Our red blood cells, for instance, they are nucleated cells in the bone marrow, okay? They have their ruboblast, prorubicite, rubicite, metarubicite, and then they turn into an erythrocyte without that. All four of those early stages before it becomes an erythrocyte have a nucleus, okay? So when it matures to an erythrocyte, it has to kick the nucleus out. Well, you can't just have a bunch of red cell nuclei floating around in your bone marrow. So one of the main jobs for macrophages is for them to eat those, the nuclei. And so they'll engulf them and break them down and then reprocess them, basically, recycle them as we go through. All right? Macrophages also play a role in producing cytokines. Okay, so they actually help produce or stimulate stem cells to grow, and even like ruboblast and prorubicites and these other ones to mature and to go through mitosis. All right, that's the reason every one of the erythroblastic islands that we have in our bone marrow, there's always a macrophage that's at the center of it, and then the cells basically surround it, and they go from immature to mature, from inside to out. Okay, it's actually a pretty amazing thing. All right. So reticular cells, they were also referred to as fibroblasts. I mentioned reticular cells earlier, but they actually produce some little fibrin strands, kind of, to give support, but also to give a place for adhesion and these kind of things. All right. And then the adipose tissue. Why do we need adipose tissue?
Fuel.
Pre-injury. They cushion our bones. They help us do that, and they can also be used for fuel. That's exactly right. Fat can be broken down into ATP eventually. Okay. All right. So, made mention of this right here. This is the two major functions in the bone marrow of macrophages. So we mentioned this, you guys. I mentioned the extruding, but we also, we talked about how that B cells and T cells, which are lymphocytes, don't hang out in the bone marrow very long. They go to the thymus gland. The B cells, though, sometimes do hang out in the bone marrow, but just not a bunch of it. But remember how we talked about B cells will differentiate into plasma cells, and then plasma cells will turn into antibodies? Well, if you've got a B cell that's a lazy ass and don't do what he needs to do, eventually a macrophage will go in and eat him, and it will destroy him. And so that's what it means by that differentiation. If they don't differentiate and mature on into a plasma cell, and then eventually the antibodies, they're not just going to hang out for free. The macrophage will destroy it. Okay? It's a good idea. I like that idea.
Kick those freeloaders.
People that don't are freeloaders need to be kicked out. Right? Differentiating cells that die in development. So let's say that you got, and here's something that we need to talk about and we'll talk about later. Y'all know what mitosis is, right? Mm-hmm. Okay. Mitosis, remember it's PMAT. Did y'all learn that in biology? You guys learn that?
A long time.
Did you learn that? PMAT? PMAT, prophase, metaphase, anaphase, telophase.
Oh, yeah.
Remember that?
That would have been helpful.
I was a biology teacher in high school. I taught my kids this stuff. Alright, so PMAT. So basically you got your cell, and it gets bigger, right, because it's doubling its chromosomes, alright? And then eventually, you get your chromosomes start lining up on the equator, and then they split here, right? Remember all that? And then you get this kind of thing happening. You got this guy over here, this guy over here, this guy over here. And then, of course, you got what's called cytokinesis as we go on. Okay? So, remember how the other day I told you you've got stem cells? And we only got really about 20,000 in our body all the time. Okay? So that 20,000 can't do the job all the time, right? So what happens is this cell is stimulated, say, we're going to talk about white cells, so we're going to say interleukin 6, okay? That's a pretty common one, all right? Interleukins make white cells. Leukin, interleukin, okay, make sure. All right, so basically what happens is this cell goes into mitosis and it divides, but it's a really unique mitosis that's only with hematopoietic cells, okay? Because usually what we do when we make these, by the time we get down here, we've got two cells that are identical, right? But the way your stem cells are designed, which is what makes them really, really unique, is they'll go through mitosis just like it does, but this guy will stay undifferentiated, all right? So in other words, it remains a stem cell. But this guy will be a neutrophil. Does that make sense? It's kind of weird. It really is. And it has to do with the way those receptors on the cell takes up that chemical, that cytochemical, that cytokine that we're talking about, okay? But, so what happens is, then this guy goes back up here and relaxes, and then this one goes through mitosis, and then this one goes through mitosis, and then this one goes through mitosis, and then this one, and this one, and so forth. And so we end up with thousands, literally probably millions of cells from one mitosis from a stem cell. So your stem cell makes a cell, and then that cell does mitosis and makes a bunch of them, okay? So we're going to talk about this later on, but see, like in the myelocytes, we have a myeloblast, and then it matures into what's called a promyelocyte, and then it matures into what's called a myelocyte, all right? And then it goes into what's called a metamyelocyte, all right? But here's the thing: myeloblasts are mitotic. Promyelocytes are mitotic. Okay? And then myelocytes are mitotic. And then here, though, they stop. Okay? So even though we got, like, this cell may make 25 cells, as it's going through its maturation, we can make maybe 50 promyelocytes or 50 myelocytes before it ages to this stage. Does that make sense? That's how you can only have 20,000 stem cells and still live, is because of the way mitosis occurs after the stem cell is differentiated. Okay? Does that make sense?
So, what is mitotic? It's just the process of
Mitosis. Yeah.
Okay.
Mitotic just means it can still go through mitosis.
Okay.
So,
And then
go ahead.
the HSC, so it only produces one identical stem cell.
Yes.
And then the neutrophil produces other
Yes.
neutrophils.
And then it continues going through mitosis. And it's kind of a weird thing because most cells don't do that. So your bone marrow mitosis, or stem cells in general, are a very sophisticated cell division. Whereas most cell division, like your skin cells, those kind of things, they don't understand. They're just basically making a clone of each other. Whereas a stem cell is being exposed to the cytochemical, but then it kind of makes the new cell, but then it wipes itself clean. And it's the blueprint again to make it. Does that make sense? At all? And so, but the cell that was exposed to the chemicals, or kept the chemicals, then it'll form all the cells that we need it to, based off of which chemicals it was exposed to. Okay? Because there's, and we're not going to get into this because that's like medtech level, but there are cytochemicals that basically control what that cell becomes, and there's like 100 of them. You know, there's certain ones that only are exposed to red blood cells to make them, you know, to make red cells. There's some that are only going to make a T lymphocyte or a T4 lymphocyte. We'll even get down to that level, T4, and then this one will only make a T8, and this one will only make a killer cell. This one will only make a B cell. This will only make an EO. You know,
That's
that
just
kind
because
of thing.
of the receptors that it has.
Exactly. And the cytokines are those chemicals that are being exposed. And those chemicals are coming from macrophages, reticular cells, you know, those kind of things. Okay? With the only exception of one, and that's erythropoietin. Erythropoietin is a cytokine, but it's also a hormone. And it's actually produced by the kidneys in our body. and it only makes red blood cells. It's what stimulates stem cells to make red blood cells. Okay. All right.
I read
So-
an article not too long ago where they were trying to keep the placenta after the mother gave birth to take the stem cells out of that and put them in.
Yeah. Well, they do that with cord blood now. You know, they actually have a program where you can bank your kid's cord blood and have it froze, have those
Yeah.
cells froze, and then if something happens to your kid,
Like,
Yeah, and it ain't
you
cheap
can
either.
pull those stem cells out and they can, you know,
After I had it.
No, you can like if,
So,
like if I had
okay,
kept one of
we
the
don't
boys'
have
bones
those
or stem
right?
cells,
Yes.
if one of
So,
them got
you
an
know,
cancer
I was
or
telling
something,
about the
you
lady
can
where
bring
the
that
acid
back
for
and
stem cells,
Mhm.
and you know, you
restart their
you
stem
said hold on
cells
to
in their
them.
body.
So,
It's
say,
like used
like,
for later,
your
it's
family
like
member
used
got
for
sick and you were a match,
But a lot of times on.
and they take their stem cells.
and you'll reproduce stem cells.
Oh, okay.
Your body can make stem cells all the time.
Mhm.
Gotcha, that's what I was.
I didn't mean that we only have 20,000 in that team.
Oh,
I just
okay.
mean
So
we
it
normally
does-
have only 20,000 active.
And it,
All
there's
the
so
time.
much
But
controversy.
no,
with
our
stem cells.
bodies constantly,
Well,
because
right now they're just using.
stem cells don't live forever. You know,
Yeah, so
if they're
much
floating around as a
controversy
stem
with
cell, and a stem cell looks very similar to a lymphocyte, it would be hard to tell the difference in a stem cell and not a lymphocyte but a lymphoblast. Okay, they look very similar. So I mean, you may actually see stem cells and you just don't know that that's what they are. But they're not going to stay undifferentiated and live for the rest of your life. They're a cell. They're going to die. So eventually. And so your body's going to basically make more of those stem cells as you go through also. I just meant you only have about 20,000 at a given time in your body going on all the time.
Alright, you ready for this question?
Maybe.
Okay, it's an opinion,
Huh?
as a scientist and a man God, you ready?
Yeah.
What is the thing that so many people have a problem with stem cell research and all that kind of stuff?
They have a problem with stem cell research because basically what they're doing is they're creating an embryo in a tube
In a lab
and then
setting,
they're destroyed.
so that's the problem.
Yeah. Yeah.
Okay.
Yeah, because what they're doing is basically, remember I told you the other day in class that, you know, you take, maybe I didn't tell y'all, maybe I was talking to something else, but you basically take, I know what it was, I was talking to my kids, we were talking about something the other day. But you
I'm
take
not
a
honestly
sperm
gonna
and
tell
an
you I've
egg.
known what that meant all this time.
Yeah, that's all they're doing. But here's what happens: a sperm and an egg, you know, get together. The sperm has half of the chromosomes. The egg has the other half. Then once they get together, basically you have this huge
ball of stuff.
orchestra
Yeah.
of cell division that begins to occur. Okay, up to a certain point, you basically have a big ball of cells that are undifferentiated. They're just a big ball of stem cells. Okay, but if that ball continues to go in I think it's like a week, 2 weeks, some of those cells will begin to differentiate. Now, technically, they are differentiated because of the chemicals being exposed to them.
But it's
But
part,
then about-
it's part of the problem coming where
then
some
about
people would
2
say that's a
weeks-
baby already, and
Well,
some
in
people would say
2
it's not.
weeks, and 2 weeks, a single cell will start beating.
Okay.
Literally. I mean,
Yeah, sure.
You know, they have. I've got a video. I used to show this video. It was called "The Miracle of Life." I used to show it to my high school kids. I used to show it to my high school kids, and I mean, it basically went in with a camera into this woman and basically filmed that baby being formed from conception.
Right.
The cells started reproducing, but what they try to do is they always try to stop it before that time. So you're looking at, you know, a ball of cells that may be 100, 200, 300 cells strong,
Okay.
but none of them have really differentiated.
Okay.
So then they basically go in and take it and they destroy it.
So,
So now
that's
they've got
where
those cells.
that's where the problem occurs, is when some people
Sure.
would say that's a
Sure.
human being and some people says it's not yet.
Exactly.
Okay.
But we have people in the world that believe a human being is not a human being until they are born
Right.
and they breathe their first breath.
Right.
So, you know, you have people that are going to have different opinions
Sure.
all the time, you know?
I got it.
I read a few, this has been several years ago, where there was a research group that were basically, they had figured out a way to reprogram cells, and they were actually taking fat cells, adipocytes, okay, and they were basically reprogramming them chemically to become stem cells. And I was trying to figure out how I can donate.
Me too.
But
I can make some make folks here.
and then as far as I know, the research fizzled out. I haven't heard anything about it.
So
It's
how
been
do they, like,
several years ago now.
you know, I heard that you can go in and pay bukus or money and choose the gender of your child. How do they do that?
It would have to be some
Reprogramming?
kind of artificial insemination kind of thing. You know?
IVF.
Because the male is the one that controls it. So what you would have to do is you would have to test every single sperm for the X and Y chromosome. And the only way they could do that would be like a electro tagging or like fluorescent tagging somehow. So they probably created some kind of an antibody that has a fluorescent tag to it. And when it meets up with the particular antigen, it's on either the X or the Y chromosome. I don't know what it is, but that's only me theory-wise can think of for them to be able to do that. And then they select that one. They probably got the little sperm glowing blue and red or something, or pink.
Okay, so if they can
Seriously.
change
And then they're
cells,
grabbing those, you know.
then why
That's
in
all
the
they
heck
have to
don't they
think
get
of.
rid of freaking cancer? If they can change stuff
Oh, there's
like that.
Well, baby, let's.
I mean, you know what I'm saying.
How can I put this?
Just lay it out there.
Capitalism is very, very good.
It's
I love-
bullshit.
But I
what
love,
it is.
but no, it's not, because the opposite is socialism and communism, which doesn't work. You know, you have to have capitalism. People have to make money. If people don't make money, nobody has a job.
Understand?
Okay, we all
I do.
can't be filthy rich, right?
Sure.
You know,
Unless you marry.
you're always going to have that. Socialism is and listen, I'm talking to you younger people, because younger people have got this idea in their head that socialism is a good thing. If you think socialism is a good thing, and I'm not talking about media, whatever, don't turn on the news anymore, because damn, you can't trust none of them.
No,
you
no,
know?
no.
I don't like. I mean,
I don't watch.
I don't watch CNN. I
No.
don't watch MSNBC. Every now and then I'll look at Fox, but Fox is just as bad. They're more, they're more conservative.
Watch
That's
local
what
news
I
for
am.
the weather, and
But
that's
who
it.
really knows unless you're seeing it for yourself? But Google Venezuela. That's all you got to do. Look at it. Look at Venezuela. It was a country that was freaking, just they were rich. They had money. They had resources. They had all this. But then when they got a socialist, basically he's turned into a dictator now, which is what happened
And they
in
went down the
Russia.
toilet.
Stalin was a dictator. No, it doesn't matter if you call it communism or whatever. It was a dictatorship. If you didn't agree with him, they could kill you. You know, that's a dictatorship. That's the definition of a dictatorship. Socialism and communism are very similar. They're not exactly the same, but they're very, very similar. Now people are starving to death in Venezuela. Okay? I mean, like their inflation rate went to, it like cost 2 million or 4 million, whatever their currency is, for an egg. You know what I'm saying? That's what socialism will do for you. So when these moron politicians are talking that, have y'all seen this Acacia? Is that her name? Have y'all seen this newest representative that's been elected from New York? She's like Cuban descent. No. There is a new Muslim one up there too. But either way, that's beside the point. But what I'm saying is, she is a socialist. I mean, like, she's a socialist. She is as dumb as a damn rock.
Yeah.
I mean, everything she says is stupid that comes out of her mouth. She made the statement the other day on the thing to this effect. It was basically, well, if we all can't be rich, let's all be poor. That's
Oh, how
stupid.
sweet.
That's stupid. That's stupid. You know? And people shouldn't fall for that crap, but they are by the thousands, and I don't understand it. You know, even Karl Marx, who is the one who wrote the book about socialism and communism, Marx, okay? they've never read his book completely, because at the end of the damn book he says it will never work. It is a great theory, but it will never work. Okay? So I was reading this
Things
study.
that work on paper that don't work in real life.
I read this study, this article. This is no true science about it, but it makes sense. So this professor at the college, okay, he said we're going to do an experiment in class, and he did it, and did it. So the first test that he gave to the people, to his class, he said, okay, I'm going to give you this test. Gave everybody the test, all right? So when the test was over, we said, now we're going to start our experiment. In socialism, everybody's equal, okay? So one person, a couple of people made A's in the class. There was a couple of B's, a couple of C's, a couple of D's, a couple of F's, okay? So he said, okay, I'm going to give you all A's because these two made A's. All right, so I'm just going to give everybody an A, all right? So everybody was happy with that, right? So they went on, and he did that every single test. By the time the third test started, you know how many A's were in the class? 0. There was absolutely 0. Everybody in the class ended up failing. The reason it is because you're going to get the attitude.
Why try?
These two A's up here, they're going to say, well, why the hell am I going to work for everybody else? Right? Where does our money come from? People it works. Well, if you're going to get welfare from everybody else, why the hell should I work? Why don't I get welfare? That's our mentality. So what happens eventually? You run out of money. You run out of welfare. Correct? That's what's happening in Venezuela right now. They ran out of money. Except for the president. He's got plenty. But the people don't. So, I don't know where the hell that came from. But hey, whatever. Okay? So, your question got me started. But here's my question. Capitalism. That's what we were
I did it on purpose. I told these guys to watch this.
That's what we were on. We were talking about cure for cancer.
Yeah.
You will never cure cancer because it's a $30 billion a year industry.
I always say when they
do
cure
it,
they make too much money.
I realize that people are gonna die. We can't have 90 bajillion people on this planet at once.
That's right.
I understand that.
And why shouldn't I make $1 off of that?
I know, but
Funeral
you
people
never
make
buried
money.
your mother due to
I know
a
that.
disease
I know that.
somebody else is living off
But do you
of.
see that? But do you see my point?
I do.
That's the point. That's the reason they'll never cure cancer in America.
There's a cure out there,
Oh, I'm sure there's a cure out there.
but they'll never.
It's too much of a
And when you get close, you'll get killed. Because somebody will kill you.
But the
Because those people who are making $30 billion
rich.
a year are going to get some drug head off the street to kill you.
Yeah,
Pays
the
$1,000
super rich people and all that don't seem to get crap like that though.
Right?
She did.
They can pay for better treatment.
That's what I'm saying, and that's what pisses me off.
But that's life. But that's life in general. That's life in everything.
I agree. I
Yeah.
don't mean I like it.
That's
I
the same
agree.
in the animal kingdom. It's the same thing in
The
animals.
strongest survive, I
That's
get it.
exactly right. Okay. All right. I don't know how we got off on that, but hey, whatever. All right. So, secondary function of macrophages. I guess by now y'all ought to know my political views of stuff. Okay. I am very conservative, and I don't really care what you think. I will tell you my opinion. So, I figure if the liberals can make you listen to them, I can make you listen to me. Right? Does it work that way?
That's right.
I hear the English professors all the time are pretty liberal around here.
Yes, especially
So-
that speech teacher.
Yeah.
Oh my God.
So I figure if she can do it, I can get by with it too.
Yeah, she
So they'll
came
probably
out
fire
all
me
the
though,
does.
because I'm conservative.
She came out the hall and got on this. Said we
Well,
were being
yeah.
too loud. Yeah, apparently we were being too loud.
Her
Her door was open.
We were
You
too
should have
loud.
said, "We're adults.
Her door was
We're
open.
paying
Her
to
door
be
was
here."
open though.
Talk if I want to.
She's like, I'm listening to speeches in here.
Say,
Well, and
well,
then
shut your
she
door.
left her door
Did you
open.
tell her? Why do you say shut your door?
I was-
Y'all
well,
are
she
adults.
came out
She
and
can't
said
give y'all a
something.
bad grade.
But it wasn't us, it was the other class because they were walking by.
Oh.
I think
Piss on her.
it was
All right. Secondary functions. Serve as the center of the erythroblastic islands. This is what I was talking about. You'll always find a macrophage in the middle of them. Okay? Macrophages are very similar to monocytes because that's what monocytes are. Monocytes will eventually leave the peripheral blood, go into the tissue, and become macrophages. Okay? So a lot of times while you're doing a diff or whatever, especially on bone marrows, you will find big macrophages. They look like big monocytes, but they're really macrophages. They get larger than what a monocyte really is. Okay? One of the things that we can do to test macrophages from monocytes is there's a stain. It's called acid phosphatase. And we can actually stain the cells with that, and they will be positive where monocytes won't. As they mature from a monocyte to a macrophage, they gain some extra chemicals that they pick up to help them with the phagocytizing of different things. Okay? And one of them is acid phosphatase. All right? So this is a macrophage. Okay? Another thing that's kind of unusual about macrophages is they may be multinucleated. Okay? Where a monocyte's always going to have one nucleus. All right? Macrophages can actually become multinucleated as we go through. Okay? Okay?
Really, that just kind of looks like a little blob of stain or something.
You okay? What was that? I never heard nobody yawn like that. Just like get it started, you know. It's like going into first, second, third gear on that yawn. All right, so these are stroma. So reticular cells, they're located in the abluminal area, which is away from the luminal surface of the vascular sinuses, and they send cytoplasmic processes to the stroma. So they basically send cytokines and different things to the stroma to help it. Okay, I left this in there. I normally wouldn't, but I went ahead and threw this in there just so that you are at least familiar with it. We're not going to go into that much detail. But reticular cells, okay, they contain a source of CXCL12, which is basically a cytokine. It's a type of chemical, all right, that cell produces. And it is the one that's basically responsible for maintaining our hematopoietic stem cell pool, okay? So we talked about the 20,000 stem cells that we have. That's our pool, okay? So if something happens to our pool, this, basically the reticular cells will produce this chemical that will stimulate the production of stem cells, okay, as we go through. All right? And all right, so every one of y'all are thinking, or you should be thinking this because I haven't been real clear, okay? Huh? I kept saying, if you make it, you know, several times I've said this. But what should have went through your brain was, well, where the hell do stem cells come from? Right? Mm-hmm. None of y'all said that. You didn't even ask. So wait a minute.
It was in the back of my head.
So basically what happens, we can't just create stem cells out of a butt. You know, they don't just come out. You know, biology teaches us a cell has to come from a cell, right? Remember that? That's somewhere in your biological career somewhere, we can't just create a cell. A cell has to come from something, okay? So basically what it does, you're never ever going to deplete your entire stem cell population, okay? There will always be some there. So what's going to happen is if your stem cell pool begins to deplete, once the reticular cells sense that, they'll start producing this chemical that will basically react to this guy, and it'll start producing a bunch of these. Okay, so instead of this differentiation here, it would form two stem cells that would be undifferentiated. Okay, and then mitosis would occur continually, but they would stay undifferentiated. Does that make sense? Mm-hmm. And basically, what this chemical is doing is stimulating those cells to go into mitosis, but it also acts as a receptor blocker, so that nothing can get to those receptors to influence them into turning into a neutrophil or to a red blood cell. Does that make sense? Mm-hmm.
So it keeps constant monitors to try to keep.
Yes, the reticular cells do. Yes, they play a role in basically monitoring how many stem cells that we have and maintaining them.
Is there something where
I don't know.
You have too many or not enough?
I don't know how it works as far as, you know, has it got eyes that says, okay, I see, 10 over there, there should be 5, let me make some more, that kind of thing. Or I see 5 and there should be 10, I guess is what I should say. Okay, but it does have a way of maintaining that pool as we go. Okay, and then we talked about how it provides that 3D supporting network as we go. Okay.
Little men with hard hats running around, right?
Yeah, it's got little robots in there.
So, like, it doesn't detect chemically if you're low on stem cells?
That's probably how it does do it. It probably does detect the chemical sensors or the cytokines and stuff that are there. So I'm sure it has a way of doing it. Okay. All right. So these are sinuses. Okay. See how you got the big open spots here? These would be sinuses in this area. These are the reticular cells. See how they're long, elongated on the ends? So they're providing a scaffolding. Okay. And so you can see how a lot of these other cells are kind of stuck to them inside there. And then you got your macrophages. See how much larger they are compared to these other cells in through there? And so this would be like a really just a punch. This would be a bone marrow punch that you're actually looking at.
Even though the macrophages just have the one.
No, there's several macrophages in there though.
I mean,
So 1, 2, 3, 4, 5. Now they're just going to be hanging out in the
I know,
stroma
but
too.
they just have the one spot in them.
Yeah, those particular ones do, but some of them can be multinucleated. I mean, these just weren't.
Are those
So
things up there that look like those things, or those?
these,
Yeah.
those are. This right here is probably. These are actually probably reticular cells that are just closer together, forming a network. You know, actual like a solid section. Okay. All right. So adipocytes, which are the fat cells, is what we talked about. They're there to maintain bone integrity. So like we talked about when you fall or whatever, so that your bones don't break. Your bone marrow eventually is going to be, because when we talked about this Monday, how that we use your kid as an example. You know, your 1-year-old is going to have all red marrow probably in all their bones as they go, but then, and I was actually a little bit early, your 7-year-old probably still does too. Technically, you may have started having a little bit of yellow marrow, but it's probably mostly red. But like a 14-year-old would start having decrease, and so the middle of the bone would have a lot of yellow, and it would start pushing out, basically, because that's what happens. Your fat, the adipocytes, actually begin pushing the red marrow so that it condenses into just the proximal end of the bone. Okay, all right. So that's what it does. Provide steroids and cytokine steroids in general. We're talking about things like cholesterol, that kind of thing as we go through. Okay, that's about it. That's all you really need to know. Okay, that's what I was talking about. First 4 years of life, nearly all marrow cavities are composed of just red marrow, and then as they get past the 4, they start getting gradually a little bit of fat, yellow marrow. Is what we call it. Okay. Of course, by age 25, we are completely that 1-to-1 ratio. Now, that kind of sounds kind of strange, but you got to remember there's more volume in the ends of the bones than there are in the shaft of the bone. So even though it looks like you got more yellow, it's actually a 1-to-1 ratio of them. They're just all pushed into the ends of the bones instead of being in the shaft of it. Okay? So by the time you're 25. And then the more you grow or the more you age, the less the red marrow is, actually. That's the reason, remember when we were talking about in phlebotomy, you can cause a patient to get atherogenic anemia for drawing too much blood on them. Remember I told you if Granny's 90 and she just needs an H&H, just do a finger stick instead of drawing 5 mLs of blood out of her arm. Remember? The reason that is because the older you get, the less production you're making of your bone marrow. Your bone marrow is not as efficient as it used to be. That's the reason even older men will become anemic eventually as they get older. They will start showing signs of anemia and these kind of things. Okay. It's also the reason why most leukemias occur at an older age than they do when you're younger. Okay. It's because those stem cells, have been there a while. They don't work properly anymore. They've lost some of their chemical signals, those kind of things, and you start seeing what we call hyperplasia or neoplastic syndromes. In other words, we see increased cell mitosis. Okay, so things like leukemia and tumors and stuff start occurring. All right. So these are adipocytes. You can see they're mostly just fat. That one little bitty one right there. These are stem cells. These are all types of cells that you see. All right. So this course is on like 10. It's probably on 10, maybe even 4 magnification. There's a megakaryocyte. We ain't talked about that yet, but a megakaryocyte is the precursor of platelets, makes platelets. So you can see why it's called a megakaryocyte, can't you? It's huge, isn't it? Yeah, it's huge compared to all those other cells. So it ought to be one that you recognize very easily. All right, osteoblast, okay? Blast sounds like breaking down, right? It's not, okay? Blast is the beginning, all right? Then you see the word blast, cell, any kind of cell that has blast in it, it is very immature, okay? It's actually the new cell. Probably it is actually the immature form of a cell, okay? We actually only have three that we think about. We have a myeloblast, a lymphoblast, and a erythroblast. Well, there's actually a megakaryoblast too, but we don't see them that often and we don't talk about them that much, okay? But there is actually one, all right? So blast insinuates new, okay? So osteoblasts are basically cells that help produce new bone, okay? So your bone is being broken down and reformed all the time in your body, okay? The same bone you have as a 2-year-old is not the same bone you're going to die with. I mean, it's probably going to be broken down and reformed thousands and thousands of times as you grow, okay? And so you have these cells called osteoblasts that do this, okay? They differentiate from mesenchymal cells. Mesenchymal cells is what they are. And they form calcified bone. They also help produce cytokines that control and regulate your stem cell activity, okay? Commonly seen in children, all right? Any kind of children, if we did bone marrows on kids, you're going to see osteoblast on the slide, okay? They look very similar to a macrophage, so you have to make sure that you distinguish those two. And then any kind of metabolic bone disease, so like osteoporosis, like multiple myeloma, those kind of things, you may see osteoblast also. These are alkaline phosphatase positive. So you remember the macrophages we said were acid phosphatase, okay? These are alkaline phosphatase. So that's the stains that we would use to differentiate a macrophage from an osteoblast, okay? She made it to the door, so I guess she'll be okay.
Let's listen and hear.
Listen, we
We
hear
don't walk out after class.
Right? So large cells are usually very, very large, up to 30 microns, which is a micrometer, same thing. They do resemble plasma cells. The only difference is the perinuclear halo, which is the endoplasmic reticulum. You guys remember endoplasmic reticulum from cell? The Golgi apparatus, okay? Sometimes it can be the Golgi apparatus. And basically what happens, it doesn't stain the same color as the rest of the cytoplasm. It's like a white looking color. And so a lot of times it's really distinct because it's right at the edge of the nucleus, okay? But the difference between it and a plasma cell is osteoblast, it tends to be further away from the nucleus, okay? And I think I got some pictures to show you in just a second, all right? This is them, okay? So these, see the color is purple, all right? And the nucleus is eccentric, which is what plasma cells do, but this is that halo. You see that right there, that area, okay? So it's the Golgi apparatus, it's perinuclear halo. In a plasma cell, it would be right here. It would be right at the edge of the nucleus. But in these, look how far away it is from the nucleus, okay? So that would be a determining factor, plus the size of it. Most times plasma cells are not going to be that large, okay? All right, so osteoclasts are what you thought about when you said blast. Osteoclasts break down bone. They're the ones that are responsible for breaking down. They're related to macrophages, but not exactly, okay? So they do break down. Another thing they can be is multinucleated, okay? So basically, they're kind of like activated forms of monocytes as we go through, okay?
So if you break a bone as a young child, does that change any of this production much? Or?
No, it doesn't. Because you're going to have the osteoblasts and class that go in and fix it. And the osteoclasts, what they do is they, like if you break a bone, say you break a bone, they're going to be able to go in and put that bone back together with a cast or whatever, surgery or whatever. But there's always going to be little pieces left inside there. And so your body senses that as being a foreign particle, and so it's going to send macrophages to be able to destroy it. Well, the macrophages that it's going to destroy are the osteoclasts. They're actually specialized macrophages that just break down bone. That's what they kind of specialize in. They actually have the lysosomes or the vesicles. That's the term I'm looking for. Vesicles. Vacuoles are just holes. Vesicles inside were like lysosomes, peroxisomes, those kind of things. They have special vesicles that contain things that will dissolve calcium, basically. And so they're able to destroy that bone and break it down and reprocess it. Yeah.
Have you heard of that disease that when people damage their tissues, it turns into bone?
No, I haven't.
I was just gonna ask if maybe that had something to do with it. They were lacking.
I don't know.
Okay.
I don't know. Maybe. Because they actually do play a role in controlling how our bones grow. So that we don't get deformities and that kind of thing.
I have heard of what you're talking about, but I've.
Yeah, I know what you're talking about. I just
When
don't.
people actually
don't
turn
know.
to stone, they say.
I don't know what exactly their problem is, though. So I'll look it up, see if I can, see if I can figure it out.
Ossification.
Dysplasia ossifications progressiva.
You know,
God bless
should I
you.
tell you what the problem is? I mean, does it say what causes it? Probably some kind of weird autoimmune
Something
thing.
enzyme.
Okay. I'll look it up. What?
That would be like the worst thing.
Yeah, that was so. What?
That would be the worst.
Yeah, I agree with you.
Get a jack, Dylan.
Okay, so these are osteoclasts. This would be an osteoclast cell. Notice this one is multinucleated. It's got 3 nuclei in it. Okay, and then of course, you got lots of cytoplasm. And when it talks about that basophilic staining, it's talking about the blue color. Okay, when it talks about basophilic staining. Okay. All right, so bone marrow, the hematopoietic cells, they're arranged in niches within narrow cavities. Okay, so this is what we're talking about, kind of with the lymphocyte aggregates, the granulocyte nest, and then the erythroblastic islands. So they're in their little niches in certain areas. Okay, so erythroblast. All right, here's a thing I need to let you know. Okay, in the bone marrow. All right, now every cell has a name. They're called ruboblast, prorubicite, rubicite, metarubicite, erythrocyte. Okay? But in the bone marrow, when they're in the bone marrow themselves, a lot of times they're just called erythroblast. You'll see that term is just a generic term if it's a nucleated red cell. No matter what stage it's in, they'll refer to it as erythroblast. Okay? And it shouldn't, but that's what they do. Okay, they kind of just lump them all in to call erythroblast. All right. So erythroblasts compose 25 to 30% of your marrow cells and are produced near venous sinuses. So around the veins, the sinuses of veins. They develop in those erythroblastic islands, like we talked about. So you got a big macrophage, and then you got the early cells, and then you got the more mature cells as it goes out around it. Okay. Alright, it's just talking about the macrophages. They're going to be there also. They're secreting those cytokines, different things, and also playing a role in phagocytosis. Alright, they regulate erythropoiesis also, which is basically the production of the red cells. That's a big job that macrophages do have. And then the granulocytes are produced in nest. They're usually close to the trebulae or the arterioles so that they can go out. They're actually relatively distant from the venous sinuses. And the reason it is because some of the chemicals for erythrocyte production actually can harm leukocyte production. Does that make sense? So they're actually designed, or your body's designed to keep the leukocyte production away from the erythrocyte. Okay? So that you don't have any cross-contamination. You don't have one working against the other. Okay? Alright, megakaryocytes, these are those large, what's polyploid?
Poly is more than one.
Big plunges somewhere.
Where have y'all seen ploid before? Diploid and haploid, right? So we have haploid, we only have what? One set of the chromosomes, right? So like our sperm and egg are all haploid. So they have 23 pairs of the chromosomes, okay? Whereas diploid is 2 sets, right? Polyploid means many, okay? basically they can be multinucleated. The nucleuses have basically fused together to look like one huge nucleus. But if you went in and did like a karyotype on it, you may find 4 or 5 in. You may 4 or 5 different sets of chromosomes. Does that make sense? So that's what polyploid means. Okay. All right. So they do produce platelets from their cytoplasm, and literally all the platelet does is it just breaks off the cytoplasm from it. Okay. And then they're located near the vascular sinus. Cytoplasmic processes of the megakaryocytes form proplatelets, and then those platelets will pinch off and become platelets. Okay? Lymphocytes, they are produced in lymphoid aggregates near the arterioles because they need to get into the lymphatic system so that they can get to where they need to go. All right? So we do have what's called a lymphoid progenitor cells, which is basically, here's what happens, guys. We have stem cell, and I kind of lied to you over here on my drawing. I left out a whole lot of stuff. I gave you the basics. Okay? But basically what happens is this guy in this division, this wouldn't be a neutrophil. This would be what is called a progenitor cell. Okay? It's called a progenitor cell. But I said neutrophil because eventually way down here it's going to be a neutrophil. Okay? But what happens is it does get the chemicals around it. But at this point, we would call it a progenitor cell. And you really couldn't tell the difference between this one and this one unless you did flow cytometry on it and looked at the actual antigens that were on it. Okay? So these are known as progenitor. And then as progenitors mature, then they start getting into the forms that we can see, the myeloblast and so forth as it goes through. Okay? So I left out a little information, but there it is. Okay?
We got the gist.
All right. So lymphoid progenitor cells are the same way. Some leave, they all leave the bone marrow, but some will stay back, which are the B cells that are going to stay. But all the T cells are going to go to the thymus gland to mature. And they'll leave the thymus gland and actually go into the lymph nodes and mature in the lymph nodes also. Okay? Bone forms the rigid compartment of the bone marrow. Any change in volume of the hematic tissue must be compensated for by change in space occupying it. So what happens, that's one of the reasons why you get, for instance, like we talked about in leukemias, okay? Leukemias, a lot of times what happens is you have what's called a hyperplasia of your bone marrow. The word hyperplasia means increase in numbers, okay? And so what happens is your bone marrow begins to increase, so therefore your bone has to increase, okay? So what happens is those osteoclasts will come in and start destroying your bone, and then the osteoblasts will try to rebuild it, okay? That's painful. Even though you might not think it is, it's painful. How many of you had growing pains when you were kids? Okay? So I knew you was tall. I figured you did. Did you have growing pains? See, I never had growing pains because I'm damn short. But my kids, both my boys had growing pains. Amanda had growing pains when she was in high school. The reason you're having, yeah, she is, about 2 inches. So,
I'm taller than my husband too.
yeah,
So.
I don't care.
Man, it doesn't
I don't
matter.
care.
My knees,
Did
my
you?
legs.
Okay, I mean, I'm not saying everybody can't have growing pains. I'm just saying the reason that you're having the growing pains is because of this process that's happening to your bones. Those osteoclasts and blasts are coming in and they're basically remodeling your bone and adding to it. So what's happening is your bone marrow increases volume, it's pushing up against your bone, and so your bone says, we got to fix it. So one of the number one symptoms of kids that come in with leukemia is they're hurting. They're sore all the time. Their bones are hurting, you know? And so a lot of times that's what happens. We push it off as growing pains, and really your kids have leukemia. And of course there would be other symptoms, but that's one of the big ones that starts it. A lot of times is the pain in their bones. So, you know, if the kid starts hurting real bad bone-wise, starts kind of running a low-grade fever, starts bruising really easily, take their ass to the doctor, okay? Because they probably are developing leukemia, all right? So, that's what our bone marrow does and how it does it, okay? So that's what we were talking about. Bone marrow hyperplasia is the increase in it. So you have an excess of normal growth, development of normal cells, but it can also be abnormal cells too, okay? This occurs too as you get older. You know, if you start gaining weight, even, your bone marrow will actually compensate by producing more cells, because it's got to carry more oxygen. So it all plays a major role with each other. Okay. Degrees of hypoplasia related to this is what I was talking about: severity and duration of the pathological state. So like with the bone marrows or like leukemias, these kind of things. Chronic anemia would be one too. If you're constantly anemic, because you eat vegetables all the time and don't eat some red meat. Are you a vegetarian?
No, I eat meat. I just don't.
What kind of meat do you eat?
Chicken, I guess. I
No.
don't eat red meat.
No chicken. Eat red meat.
I don't like it.
Learn to like it. Okay? Are you taking iron supplements?
I'm supposed to.
I figured you was
Would you like to
really
eat
truly. I could look at you and tell you're
Read you a rare steak.
Medium
So,
rare.
you need to start taking some iron supplements.
Yeah, that's what my
Medium
doctor
rare.
said. I had six.
So, being personal, do you take the
Rare
last
to
pills?
medium.
I do.
Do
It
you
has
take the last
iron.
pills? Do you take the last of them or do you skip them?
Oh,
Start taking them.
Yes, for God's sake, all these girls that skip that freaking week, they're there for a
See
reason.
them all the time. They skip them every time.
The week
They
that
think, oh, it's
pills.
just sugar pills. It's
No, my
not.
doctor
It's
told me
iron.
it was iron.
Yes,
It says
and there are
Fe.
actually lots of iron in them too.
Yeah.
Because as soon as you take that last one, what happens? Your period starts. So you know you're going to lose blood, so it's a compensator.
They're there for a reason.
All right.
I'm
You need some
actually-
liver. Eat some chicken livers.
Oh,
you want to
that
eat
sounds so
chicken?
good.
Get chicken livers.
That's gross.
They're not gross.
Yes.
Don't make
That's
me
all
so
that
hungry.
they're for.
I don't eat
You
beef.
say I'm skinny. I'm
But I
taking
eat enough
this
steak and hamburger ribs.
I don't like it.
You're going to have to learn to eat
Then you
it.
ain't had the.
Let's say you never
I
had
don't
good
like
steak.
steak.
My wife don't care for steak. Then if you're not going to venture out and eat steak, you need to get you some iron pills.
I'm actually supposed to be taking like a high dose.
There you go.
The B12,
There you go.
but
Gotta have all that
I
stuff.
don't because I don't know.
Because you're a woman. Somebody, he don't tell me what to do. All right, and acute blood loss, that would be something too. Even if you had like a car wreck, okay, and I know this sounds crazy, but if you had a car wreck and you had a trauma and you started bleeding profusely, your bone marrow would actually stimulate and start growing more, and it would start breaking bone down to make room for it. Now, it'll probably regulate itself out after a few days, but at that particular couple of days, it would definitely compensate or try to compensate and cause hyperplasia to occur. Okay? If you had a person that had a car wreck and had a bad bleed, and you did a bone marrow aspiration on them, it might even look like they've got some kind of erythroblastic leukemia because they would have so many red blood cells there in that. And all it is just a natural response to a trauma. Okay?
What
As we
is,
go through.
remind me please what it is, like if you sprain your ankle and the swelling, what is?
That's blood most of the time.
Yeah,
You've torn the muscle or the
Yeah, but
tip
I mean, what's
ligament.
that
That's what
swelling?
the swelling.
Blood.
Edema?
An edema, I mean, you might get
Yeah,
some
it's
edema,
not
some
what I'm
inflammation and
thinking
stuff.
about.
But a lot of times, if it's a really, really bad sprain, it's blood, where you've actually torn something.
Oh,
That's
yeah,
why
I've
that
been there,
bruise
done
forms?
that.
Huh?
Is that why that bruise formed?
Yeah, that's it. That's all bruise is, just bleeding under the skin. Okay?
Yeah.
The body's emergency fluid.
Huh?
Yeah, what is that fluid that's like the emergency stuff that goes right immediately?
It's like, I know what she's talking about. It's like an emergency.
I don't know.
Because I know a lot of times the swelling immediately is a protection
Huh?
of that joint or whatever.
Really?
I used to know. There's a word for it. I
Not
don't know.
unless it's like lymphatic fluid.
That.
Is that it?
Yep.
It's just lymph.
Yeah, that's what I was trying to think of. Thank you.
Okay. Glad I can help. I'm trying to, my
That's
brain's
exactly what I
trying
was
to,
trying to think
because you
of.
can't just automatically lose fluids, I mean,
Yeah.
there has to be, a compensator, so it has to either be plasma or lymphatic fluid. That's
Yeah.
really your only
Did
tool.
you know, like, if you first
Sure.
sprain your ankle or you bend your finger backwards,
Sure.
an initial swelling
Sure.
is your oh crap mechanism kicking in,
Exactly.
and it's trying to
Usually
protect
your
that.
lymphatic system
Okay.
does that. Okay? Alright, so bone marrow hypoplasia. You need to learn hyper and hypo if you don't know that at this point. Okay? Hypo means below, so this is going to be a decrease in production of your bone marrow cells. Okay? So basically, tissue becomes inactive, fat cells increase. Okay, so you're going to get an increase in your fat cells. And then it usually it's usually chemicals or toxins. So even something as simple as like chemotherapy will do this. And that's kind of the whole point of having chemotherapy is to destroy your bone marrow when you have leukemia, is to try to knock down the cell growth in the actual thing. And it can be genetic too, but very, very rare for actual genetic. All right, blood cells migrate from bone marrow to the circulation. This is called egressing. All right, egress, I think is the term. Egress is when it migrates from one place to the other, and they do it through the endothelial cells. Okay, so basically, I know it's time, but let me finish this. Basically, your endothelial cells are like this, lined up. Okay. So what they've got to do is they've got to squeeze through them to get into the bloodstream. So like this is your bloodstream right here. And then we have these, you would have the endothelial cells here also. Okay? So they've got to figure out a way to get through. And a lot of times the endothelial cells will actually contract a little bit to give them a little opening to be able to get through when they do become mature. Okay? So it's called egressing. Yeah, that's the word. Blood cell egress. It's not that important. That's basically what I told you. That's basically the same stuff I told you. See, I hate this PowerPoint actually because it's got like one word, you know. Let's have y'all freaked. I bet y'all all freaked out when y'all saw 300 slides or whatever. But the reason is because they've only got like one bullet on each one, and they've got it in like a 45 font. You know what I mean?
Is there like a wave on your slides? Because it makes it look like it's kind of waving through the.
Yeah,
the
the words are moving.
I think it's.
I think it's the screen itself.
the wind coming in through the windows.
It's
It's not that. Y'all see the words like they wave. I'm dead serious. I've been sitting for this whole semester looking at it, and every single one of your slides does it.
Well, I'm gonna if it's
It does.
every one of my
Like it
slides.
has movement.
Yeah. Every one of your
If
slides
it's
is
every one of my slides, it's the screen itself. Because these are from two different companies.
wave.
And I'm not smart enough to make it wave.
You gotta consider body.
All right, we'll finish right there. That's good.
Like I said,